Well, good day, Physics 20 students. I have another short lesson here for you today. Although it's short, it's extremely important concepts, namely Newton's three laws of motion. So Newton proposed these three laws of motion that would describe how and why objects move. And the first of the three laws has to do with how objects behave when there isn't a net force acting on them. So a net force, a non-zero net force, is a force that will cause something to change its uniform motion. So basically what Newton thought of, which was different than scientists and philosophers before him, is that he said objects would just keep moving in uniform motion, and they would stay in uniform motion unless there's a force acting upon it. For example, if you've ever run along and slid on ice, well, technically you just could slide on forever, except for even on ice there's some frictional forces that slow you down. And so for example, also when you're driving a vehicle, as soon as you take your foot off the accelerator, the car starts to slow down. And the only reason why that occurs is because there's a frictional force, air resistance and friction on the road that slow you down. But something like a object moving in space, unless gravity is acting upon it, it'll just stay in uniform motion because there's no air resistance or friction acting on it. Newton's second law is a mathematical formula. It's just the net force is equal to mass times acceleration. So there's lots to this formula, even though there's only three variables. But what you'll notice is that if the mass is constant, then the larger the force you have, the greater acceleration you have. And you can think of that in pretty well any sports. If you apply a strong force on a ball, it's going to accelerate much quicker than if you just apply light force. Think of smashing a birdie in badminton or in tennis, or think of throwing a baseball. You have to apply a strong force if you want a large acceleration. The flip side of that is if you have a strong force and a small mass, you can get a big acceleration. For example, if you're throwing a baseball, the mass of the ball is fairly small versus if you're throwing a shot put. If you're throwing a shot put, because the shot put is much more massive, it's going to have a much smaller acceleration with the same force. So it's a mathematical law of motion and really practical. And I'm going to give you some examples of using that in another video. The third of Newton's three laws has to do with the idea that for every force on an object, there's always an equal and opposite force that's acting on the other object. Let me give you an example of that. I think quite clearly we understand that gravitational forces keep us on the Earth. So let's say we're jumping off a diving board. Well, as we accelerate towards the Earth, technically the Earth also accelerates towards us. The same gravitational force that we feel towards the Earth is the force that the Earth feels towards us. Now, clearly the Earth doesn't move towards us, and that's because it's very, very massive. So the gravitational force that the Earth exerts on us is the same gravitational force that we exert on the Earth, but the Earth is so massive it doesn't really have a very big acceleration. Whereas for us, the gravitational force is going to give us an acceleration of about 9.8 meters per second squared. But even if you think about jumping, how do you jump? Well, you actually push down on the ground. And as you apply a force down, the Earth applies an equal and opposite force on you, and that's the reason why you're able to jump up in the air. So we rely on this all the time. Now, these forces don't really cancel each other out because they're on different objects. So when we push down on the Earth, we're applying a force down on the Earth, and then the Earth applies a force back on us. So after we're pushing down on the Earth, we experience a force for the Earth pushing on us, and that's what makes us jump. The forces don't really cancel each other out. They're just equal and on opposite directions on different objects. Anyway, these are Newton's 3 laws of motion. They're pretty significant, huge concepts, and describe motion and our further work on dynamics. Thanks for tuning in to this YouTube lesson. I'm hoping that this week I can set up a couple of Zoom classes to be able to answer some questions and give you some further instruction. So pay attention to Google Classroom, and I'll keep you informed.